Good day. Okay, today I would like to share with you on this topic for the course of Theory of Computer Science. So the first topic will be Theory of Sets. Okay. Okay, so this course will introduce you to formal language and automata theory. This course also emphasizes on grammar, regular language, and abstract machines. Okay, to practice the acceptability, and then at the end of the class, the student should be able to apply the theory in constructing the abstract machine and testing with right data. Okay, what is set of theory? Okay, I think you have learned this during your upper secondary, maybe. Okay, it's actually what we have learned previously during our school age. Okay, a set is an unordered collection of objects, numbers, and symbols. As you can see here, S is equals to X, Y, Z. Okay, then we represent it as set membership. Okay, and it can be written as XYZ is element of S. If it's not a set of membership, it is written as ABC and not element of S. Okay, so it can contain other set as elements. For example, here you can see example S1. There is another set of elements here. Okay, or here. So this is also called as set. Okay, and in set of theory, there is no duplicate. Okay, for example, here we have 2. So this is not a set. Okay, what is cardinality? Cardinality is number of element in a set. For example, here we have A, G, I, Y, Z, M, N. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 number of elements. So the cardinality of this set is 7. Finite set and infinite set. So finite set is a set with actually the actual numbers. Okay, actual numbers without any dot behind. Okay, so it is not infinite. So this is example of infinite set. It can comes like this. 0, 1, 2, 3, blah, 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 blah. Okay, this is also considered as infinite set. So what is empty set? Empty set can be represented as brackets or phi. Okay, or sometimes we mention it as empty set. Okay, so the cardinality of empty set will be 0. Okay, the cardinality is 0. Okay, there is another term which is singleton set. Set with only one element. Okay, so this is an example. And this is called as singleton. Anything with only one element is called singleton. Okay, we represent set specifications, okay, using this kind of phrase, okay. These are the four examples that are normally used in mathematical book or computer science books, okay. So the set specifications can be represented as S equals to, in bracket, X, where X has a certain property. Or we can represent with this symbol, X, where X has a certain property. Okay, this is also an example on how we represent where X is the male student in this section, for example. Okay, and then the final one, here we present Y, where Y is the female student in this section and with the age of more than 20. So these are some examples of set specifications. Subset of B. So we represent it with A is a subset of B. Or maybe if you use another variables, Z is subset of Y. It can be any variables that you would like to. This is just an example. A is a proper subset of B. Okay, this symbol represents a proper subset. Okay, but if the condition with A is not equals to B, so different from a subset, a proper subset is not equals to. This is an example where A is equals to 1, 3, and 5. Then B is equals to 1 and 5. Okay, B equals to 1 and 5 is a proper subset of A. Why? Because A is not equals to B. The set C equals to 1, 3, 5 is a subset of A, but it is not a proper subset of A since C is equals to A. Okay, so power set. What is power set? Set of all subsets including the empty set and the set itself. For example, we represent power set with this symbol. Okay, whereas, for example, here the elements are 1, 2, and 3. So the power sets of S will be all the sets inside of S, including the empty set and also the set itself. So if S equals to 1, 2, 3, so the element will be empty set 1, I'm sorry, 2, 3, 1, 2, 1, 3, 2, 3, and the set itself. Okay, so